I appreciate that, Mike. Great pleasure to be with you here today and to join the DroneSec GDSN. I think this is an excellent conference. My name is Ryan Wallace. I primarily perform data analytics on unmanned aircraft systems at Embry-Riddle Aeronautical University, working for a number of different entities. But I'm really excited today to share some of the results of several different studies that we've been working on dealing with countering UAS threats, and in particular, how we leverage that UAS detection technology to benefit the agencies that are making decisions. And so, very excited to share that with you today. Before we actually jump in, we have to kind of understand what exactly is a threat. And I think it's very important to start out with a basis of this so that we truly understand the context of all of the other data. So, first of all, when we look at threats, we have to understand that it's a capability that's matched with an intent, and typically an illicit intent, in the presence of some sort of a vulnerability that truly creates that threat. And so, when we look at an unmanned aircraft, that is providing a unique capability to an adversary. That adversary has an illicit intent to leverage that capability for a very specific purpose, and then ultimately to exploit that capability against a vulnerable security system, which ultimately creates that threat. And so I want to provide that kind of early context so that we can have a discussion related to that particular element. When we look at these threats, there are several different issues or criteria that make something more or less of a threat. And I kind of broke it down into three basic areas. I really like the research that's been carried out by a research team known as the Latcher team. And as we look at UAS, typically the more robust the UAS, the more automated the UAS, and the more diverse, that creates more challenges for us to be able to counter that technology. And a good example of that, you look at the automated nature of certain types of unmanned aircraft, DJI being perhaps the most prominent. Why is it that only now we are seeing so many more problems than years back when they had RC airplanes? And part of the reason is because now in the unmanned aircraft system world, things have become much more automated. You don't have to have a significant degree of skill anymore to allow an unmanned aircraft to be very, very accurately controlled and to perform a mission. And so that result of automation makes it easier for someone to perpetrate an illicit act. Again, the more robust the UAS, that's going to make it more challenging to counter it. And finally, the diversity based on the configuration of the unmanned aircraft. And a great example of this is some home-built UAS because they don't conform to off-the-shelf types of unmanned aircraft. It makes it more challenging for us to prepare. How do we go about trying to counter this technology? Because it doesn't necessarily apply to a box set, if you will, to something that's very commonly out there. So just some interesting context with regards to the capabilities. In addition to these capabilities, we are essentially giving the civilian population access to what was normally limited to a military asset or a government style asset. We're making it affordable for them to fly, to deliver objects from the air, which is a new threat vector that we have not normally considered. And I think that's interesting to consider as well. So that's basically assessing the threat. When we look at the threat actors, the Federal Aviation Administration would basically say that there's three, and they call them the clueless, the careless, and the criminal. I truly believe that there are a larger number or a larger spectrum of threat actors, and it truly starts out with the compliant, the people that are out there following the rules. And so from the compliant, we get more and more aggressive, if you will, starting with the clueless, the people that don't know that rules exist, the careless, those that are aware of the rules, but they fly anyway, they don't really care. The crazy, those that are doing extreme disregard, they are flying with a level of negligence involved. Those that are criminal, that are supporting some sort of criminal operation. And finally, the committed, and we're going to basically consider these the terrorist or domestic terrorist, if you will, that have full intent of using the technology for some sort of an illicit purpose with the intent of harming or killing. And I think we see that spectrum being a very important element when we start looking at unmanned aircraft system threats. So again, providing more context to how we leverage this data. Based on some research that was performed, actually dating back to about 2015, the research team that I worked with identified 12 different areas that unmanned aircraft systems are actually out there producing problems. And they basically come into three different categories. The first category is commercial off the shelf threats. You can go to Walmart, you can buy a drone off the shelf, and purely by that capability, you now have the ability to perform certain types of illicit actions, such as a nuisance. You can fly over your neighbor's yard. A classic example in the United States would be, of course, the individual, the Kentucky drone slayer, where an individual flew over the neighbor's yard. The neighbor thought that the individual was spying on the daughter, and as a result, he took out his firearm and blasted the drone out of the sky. Interference threats. Obviously, Gatwick has come up several times, but we also see California, the wildfire suppression operations being interrupted as a result of an unmanned aircraft being out there and presenting a threat to aircraft. A monitoring threat. I think one of the more interesting monitoring threats I read about was actually in the United Kingdom, in which a drone was suspected to be monitoring an ATM machine looking for PIN codes. And I think that was kind of fascinating. The propaganda threat. Here in the United States, we've had a few cases in which an individual that is frustrated with the media was dropping pamphlets over major NFL games. And so we start seeing all the different elements come together to codify some of these different threats. Certainly with the payload threat, now we're taking it a step further. We're using the drone as a delivery system, and typically with some very, very rudimentary modification, and in some cases no modification at all, we can actually leverage that UAS to deliver something. And we see that particularly problematic in the prison system and also along the border. I think what's interesting about this is we see some very, very common types of issues. And one of the most common issues is if you've got a drone that has taped lighting, almost 99% of the time, that is some sort of indication that something is not right. And finally, the weaponized threat. These can range anywhere from a non-lethal style of weapon, where we have modified the unmanned aircraft to be weaponized, to a projectile threat. Basically, I think about the individual student that, with the assistance of his professor, attached a firearm to an unmanned aircraft in the United States, and we actually later attach a flamethrower. And I think that's interesting as we start to add that additional threat capability to these unmanned aircraft systems. We really add to that threat component. IEDs and explosives certainly being felt over in the deployed locations for the American troops, for example, incendiary threats, and even to a certain extent, WMD, or weapons of mass destruction, those chemical, biological, nuclear, radiological, etc. And we saw even in Japan, an individual that was frustrated with the government response to Fukushima decided that he was going to collect some soil samples around the Fukushima power plant and send that to the Prime Minister of Japan. And so when we see all of those capabilities employed, we see the spectrum of all the different types of illicit applications that can be performed. And the innovation is still out there. People are still coming up with new and different ways to use UAS in an illicit fashion. So we have a couple of vulnerabilities, at least in the United States, and to a certain extent, I would say, within the world. And they really come down to about 5 different components. The first being the threat novelty. This is a brand new piece of technology, and typically the regulation lags the innovation. And so when you have that new technology, local law enforcement, local governments are truly not prepared to respond to this style of a problem. Additionally, there's limited mitigation authority. In the United States, there's only 4 agencies: the Department of Defense, the Department of Energy, the Department of Homeland Security, and the Department of Justice that are allowed to mitigate or actually bring down drones and under very limited conditions. And when you consider the vast quantity of unmanned aircraft that are out there, that may not be adequate for the need. And then you add to that there's lagging legal solutions. How do you prosecute these cases? In fact, many laws are not yet written to deal with the kinds of problems that we're seeing in many of these cases. Adding to that, we put another element or layer of expectation on law enforcement to deal with this problem. And with the United States being a country that typically will defer, well, we'll call them social problems to law enforcement, we're really creating a challenge for law enforcement to now solve that they may not necessarily have the right resources for. We understand as we look for UAS out there that it's not something that we can just use the Mark II eyeball to see. In order to have the appropriate kind of response, we may need specialized and very expensive equipment in which to do that. This would be things like the detection equipment or potentially mitigation equipment that is not readily available or not legal for people to use. And I think the final component, and this is perhaps one of the most challenging to solve, is that this can potentially involve social deception. So if someone is using a UAS for an illicit purpose, it's very easy to cloak that activity in something that's seemingly legitimate. If an officer approaches an individual that's using a UAS and that individual may be scoping out a property for later theft, he could say, "Hey, I'm just flying my drone. I'm having fun. Why are you bothering me?" And it can very easily be masked under the auspices of being something that is a legitimate activity. And so I want to highlight all of those problems before we start talking about data, because I think that really does formulate the basis of really where we're going here. So this leads us to understanding why we're scared of the UAS problem. And in a great acronym capacity, I've provided a couple of different reasons about why it's so challenging to deal with the drone problem. First of all is the scale. We have a very widespread problem. I'm going to show you some numbers here that just show you the proliferation of where unmanned aircraft systems are going and how far that they've spread. The unique capabilities that are offered by unmanned aircraft that are only increasing. In many cases, almost like the cell phone industry, we're seeing that drones can do more and requiring the operators to do less. And that added capability makes it easier for people to use it for an illicit capacity. The anonymity, the ability of using that unmanned aircraft at an offset or geographically separated distance now gives the perpetrator an ability to escape and the ability to remain anonymous. So they really don't necessarily have to put themselves out there to perpetrate some sort of an illicit act. Because the UAS is also relatively easy to modify, in some cases, just by purchasing something on Amazon, we can now retrofit it and make it do things that it wasn't originally designed to do. A great example is the commercially available devices that allow you to drop things from a drone purely by activating the drone's lighting systems or from an alternative RF remote. And so those retrofitting really do allow the operator to modify that platform for something it's not necessarily designed to do. Emerging applications, okay, as I mentioned before, we yet don't know how many different ways that drones can be used in an illicit fashion, and our understanding of how they can be used in those illicit fashions are still evolving. So because this is a new technology that is going to continue to lag until we've seen all of the different ways that people can perverse this technology for an illicit purpose. And finally, I think the one thing that is really interesting is how unmanned aircraft are now becoming at the level of disposability. In other words, if I use this UAS for an illicit purpose, I don't feel too bad about abandoning it, because at the end of the day, it doesn't cost me much money. And I'm more concerned about being caught than I am about losing the $500 or $1,000 drone. And so it becomes disposable. And a great example of that is we actually look at the narcotics trade on the border, where we have cartels that are using unmanned aircraft carrying tens of thousands of dollars worth of narcotics, but at the same time they're flying a $500 or $1,000 drone. So it really is interesting when we start looking at the economics and how unmanned aircraft are supporting that economics. So that's why we're truly scared of the UAS problem. And those are some of the elements that I think we still need to solve. As we start looking at unmanned aircraft data, it's important to understand that there's basically three different components of data. There's personal truth, that's the truth that we believe, in my experience. The second component is we not only have personal truth, we have political truth. And this is a little bit scary because it is based to a certain extent on the biases of individuals or organizations that are reporting that information. And finally, we have objective truth. And I want to credit Neil deGrasse Tyson for that, because I think that matters heavily about how we look at truth and how we look at data. And so as we evaluate it, our objective is to come up with that objective level truth. In other words, it's agreeable regardless of who is looking at it or what biases we have. Well, the FAA is starting to provide us some of that information out there, and they have certain projections about what the drone industry looks like here in the United States. And their estimates suggest that we have roughly 2 million to 3 million unmanned aircraft, depending on the count that we believe at the time. And you can see the breakdown there. Most of those unmanned aircraft are not very expensive. They're about $750 or less. And we're seeing a relatively high growth rate approaching 10%, with the consumer grade or the commercial grade actually accelerating even faster because of that economic benefit. So I think that provides us kind of the initial gut check of where the industry is going, at least in the United States. And you can actually see some of the breakdown of the registrations by location. It's exactly where you'd expect it to be, typically in urban areas, more developed areas where the populations are. And so I think that's kind of interesting to understand. But we're going to expand that and kind of develop a better understanding of what data is out there and what it means. But before we do that, I want to talk a little bit about the data that the FAA currently uses as a proxy for measuring what's truly going on out there. In late 2014, the Federal Aviation Administration decided that they were going to use UAS sighting reports as a proxy for measuring risk in the national airspace system. And the reason that was selected is primarily because we don't know what's going on. Unlike a radar or an ADS-B device that's able to project or detect manned aircraft, we don't have the same thing for unmanned aircraft. There is no national system for detecting the unmanned aircraft that are out there. And so we really don't know what the flight activity in various locations looks like from day to day. And so in lieu of that, what seemed to make the most sense is we're going to evaluate any time that a pilot or an air traffic controller or some other aviation-centric entity reports that they've seen a drone. And this is a little bit dangerous. If you look at the history there, we are generally increasing in the number of both annual and monthly reports over time. There was a relatively lower recent history, but now in 2021, we've blown away all the records. We're seeing about 401 reports as of June of 2021. And we really don't know where that's going. But the problem is not necessarily these reports. I think this is a terrible metric that is currently being used. First of all, it's very subjective. So if I'm in an aircraft and I say, hey, I saw a drone, it doesn't necessarily mean that anyone is doing anything wrong. In fact, I would probably articulate it as having the same effect as me reporting every time that I saw a firearm. Now, everything is contextual. If I see someone carrying a firearm and they carry a badge as well, that wouldn't make sense for me to report that. It's a law enforcement officer, or potentially a military person. So again, the logic of the perceptions of the pilots reporting purely the presence of a drone doesn't mean that anyone has done anything wrong. It is purely an observation that a drone has been spotted. Now, in several cases, the pilots have also subsequently reported that an unmanned aircraft was in near proximity to their UAS, or excuse me, their aircraft, and there was a collision risk. But again, this is subjective. So we don't know the level of accuracy of some of these reports and the level of accuracy of the pilots reporting them. So it really creates some problems. The other problem is what is being reported may not even be a UAS. It could be other things, balloons, kites, other aircraft. The point being is now that we're in a UAS craze, and I think to a certain extent Gatwick has almost projected us down that path, everything that is seen out there is a drone. It doesn't matter what it is. If they saw something out of the blink of an eye, it's going to be a drone report. And I think that's one of the scary parts about the drone craze, if you will, is a complete lack of data validation. We don't know what level of accuracy this data has in any way. And so I wanted to highlight that. Before I go on to kind of the justification of the data, I do want to talk about just how challenging it is to look and see a drone. So without further ado, I do want to show you some research that our team has been working on since about 2015, in which we put up a test center and we flew a general aviation aircraft in a collision course style capacity with an unmanned aircraft with a small separation that was built in. And so I'll briefly show you that video, which is on this next slide here. And you'll be able to see, I'll point to it with my cursor when we actually see the drone. It's a lot harder to spot than you might imagine. Here we go. So again, you can see the aircraft in flight. It is approaching landing at a runway. The drone is extremely small. This is basically a Phantom style unmanned aircraft. And I even have trouble seeing it. You can see it right here, just in the blink of an eye there. There's 3 more passes. It'll take about 60 seconds for us to finish the remaining video, but I'll do my best to show you where these unmanned aircraft are actually spotted. Now, if you ask yourself, how often are the pilots spotting these devices? The answer is about 10% of the time. And so we may have many more encounters than you actually might think. We've done several variations of this study, including in cruise flight and also on approach to landing. We've also performed this study at night. So we have a pretty good understanding of the capability of the human eye to being able to recognize this. Additionally, one of the serious challenges for this type of activity is, and here you can see the drone on the right side this time, is truly understanding what the pilot is going to see. And the movement of the drone becomes very important. Our eyes are naturally going to be looking for that movement, especially if it's in the periphery. So if we don't have that movement, if a drone is hovering, that actually makes it much, much more difficult to spot. And here we are one more time off to the left-hand side. So you can see the challenges associated with just locating that unmanned aircraft visually. And I wanted to give you that context. So as we look into the next slide, I want to take a moment to show you how we can leverage data to better understand what is going on. So one of the things that we evaluated is at a top 10 airport in the United States, we actually looked at when these sightings were occurring, if we could correlate that activity with drone detection equipment and understand, was there actually a threat created? And so I'm going to give you one example of this. You're going to see a couple of things. One, you're going to see the ADS-B track of the aircraft as it comes into landing. We've excluded all other aircraft, so obviously there's more air traffic activity that's going on. And then you'll also see the aircraft, or excuse me, the unmanned aircraft events. They're going to pop up as green telemetry files. And you'll note that I've recorded it for an hour worth of activity that you're going to see in about 40 seconds. So without further ado, let's get into that. And so again, you see the pop-up aircraft, unmanned aircraft activity. Eventually, you're going to see the manned aircraft enter the screen. And even though that there was a sighting here, you will note that there was no unmanned aircraft that was anywhere near that UAS. Now, our detection technology does have some limitations, and obviously we are only looking at a specific manufacturer's unmanned aircraft. In this case, it's DJI. But what you're seeing here is the level of activity around the airport. Again, now we can look at this data objectively. We can see what altitude is it at? Where is it at? Is it in a Lands grid? Is it in other locations that would make it appropriate? Now, before I scare you, I want to give you some context. We've done a great deal of analysis, and part of this analysis was done at, again, a top 10 airport in the United States. And you can see here the level of UAS activity over, in this case, a period of 37 months from August 2018 to August 2021. And the highlight here is really there's a lot more UAS flying that's going on than you probably realize. So what you're seeing on the screen represents about 30,000 platforms, just over 475,000, so almost 500,000 flights. And we can see that the activity level is extremely high. From what we've evaluated based on the sighting reports at these locations, we have not yet seen that UAS are causing those serious issues. There's still ongoing analytics to evaluate when sighting reports were not incurred. But the point being here is there is a ton of activity, and we're not seeing the airplanes fall out of the sky yet. So this is really encouraging news. However, I think it comes with a little bit of warning that the scale of the problem may be a little bigger than we originally thought. And I want to kind of highlight that because there is a lot of activity here, and that also means there's a lot of data analytics to be done to understand what is in fact going on. Just to give you an idea, this is another study that was performed in Miami, Florida, around the port of Miami, primarily for security reasons. You can see the spaghetti diagram off to the left, looking at all the drone telemetry. All the origination points off to the right. One thing that was interesting about this study is because of the capability of the sensor we're using, we're able to identify individual unmanned aircraft by a serial number. And so we have access to that serial number. We can tell how many different UAS there actually are, their type, and some other basic information, which allow us to do population counts. When we performed this population count, the population was 10 times higher than what the FAA's report at the time, the UAS registration database, said it should have been. And so I think that was very interesting to provide that context. And we're really only looking at about a 15-mile radius here. So I think that's kind of interesting that we may not be getting the full picture, because the full picture relies on compliance, that people register their unmanned aircraft as they're supposed to. Well, that doesn't always happen. So what we're looking at is primarily Dodge Island, which is in the center of the screen. And on Dodge Island is the port of Miami. It's one of the largest cruise ship ports in the world. And I think it's kind of interesting when we start looking at individual telemetry elements, because we can start identifying where they present potential security risk. You note the launch locations of the white boxes. The telemetry files are actually the data points. And here we have a perfect example of an individual that launched an unmanned aircraft in an unsecure area. This is where the public is allowed to be, overflew a security screening area, and merely the fact that they've overflown a docking position for a vessel shows the capability, not necessarily the act, but the capability that they could have injected contraband if they had the unmanned aircraft appropriately equipped. And again, we're showing that capability of things that we may need to protect against. Here's an example where there was an origination from a vessel. Someone launched a UAS from the docked position of the vessel. That shows the alternative, that a contraband segment could be injected before someone is screened back into the country after departing. And again, that shows other security problems that we may be encountering. Perhaps one of the most serious events, when the port asked us to come in and evaluate this, they said, hey, we don't have a drone problem. We've never seen a drone. There are no drones operating where we're at. And the truth is that's not exactly what we found. In fact, there were so many drones, we actually had to limit our analysis just to those that were flying over Dodge Island itself. And there were about 60 of them. And so what we saw, and this was particularly concerning because of the lack of information, this is called a DroneSec pattern. Most of the time, these types of patterns are used primarily for mapping or surveying, but we saw this pattern at multiple intervals in the same location. And when you start mapping over time, we call that in any other industry intelligence gathering. We're looking for change detection. And we saw this same type of activity 3 different times over the very small course of our sampling period. And so obviously that starts to raise questions, particularly since the Ports Administration wasn't aware of this activity going on. Other types of activity that was noted, we did see activity on the eastern portion of the island. This is the area that actually is protected by access controls. So an individual would have to show their card or their badge in order to access this area, which now leads us to ask, why is an employee using a UAS? Why is an employee using a UAS without knowledge of the Port Administration? Is this an insider threat? And again, those are more questions that we can now ask ourselves. Another great example, and this is probably my favorite example, you'll note the building that I'm highlighting here with my mouse. You'll note that reverse L-shaped building is actually the security building for the Port of Miami. That's where they deploy most of their officers and they manage the security infrastructure. Across the street in a multi-story parking structure, we actually have the launch of an unmanned aircraft. And I think it's interesting. You could say that this launch occurred under the very nose of the security headquarters. And so that's, again, another perfect example why, given the lack of technology, our existing measures that we use for detection, the Mark II eyeball, the reporting officer, may not be effective to deal with this kind of threat. So those are some of the challenges that we see, particularly from a security standpoint. The last thing I want to talk about is really how we use data. And when we look at data, we really try to leverage the most out of that data by integrating 3 different types of information. One is telemetry data. This would be information from UAS detection sources. In other words, what is the UAS doing? We also integrate aircraft or ADS-B data. So again, another form of telemetry. And then we integrate that with static GIS data. That might be critical infrastructure location, airspace data, data that basically doesn't change, it's static. And then finally, we also include active GIS data as well. That would be things like weather information. Of course, weather is going to change in different locations over time. Information from the LANC system, the UAS data exchange. And we start putting all of that together into a puzzle that starts to build situational awareness about what is really going on in the national airspace system. And I'm going to show you several different examples. We're doing quite a bit more than what I'm able to brief you on, so I just want to highlight that. Here's a first example of looking at compliance rates. And so here we want to understand, well, how many drones are flying above 400 feet? And so by looking at all of that information, we're actually seeing that it's a really small number. It's actually less than 6%. But as you start building the picture, we now can understand there may be more going on here than meets the eye. So if you look at the bottom chart, you can actually see that over time, we're actually seeing some relative improvements until, of course, we hit 2021 and the percentage rates are going up. But in order to make the most sense out of data, we've got to dig a little bit further and answer the whole story. So a great example of how we've done this is you can see the chart at the right. We ask ourselves, well, what unmanned aircraft are contributing in a disproportionate level to these higher altitude flights? And you'll notice that the flight breakdowns from 500 to 1,000, 1,500, and 2,000 feet, we can actually see which unmanned aircraft are more non-compliant than others. And so any unmanned aircraft that has a skew to the right here has a disproportionately high contribution to that excess or that non-compliance area. So FPVs and Inspire ones tend to have a higher number of flights that are in excess of that 400-foot boundary. And so we got to ask ourselves why. And so now it starts to paint a picture of what our threat might look like. And so the easiest way to think about this is you don't know what's wrong until you know what's right. And so if you understand what the normal operator behavior looks like, now you can use that data to then understand what is abnormal. And I think it's very important to understand that until you won't know what is normal, you won't know what's abnormal. Here's another series of analysis that we've done. The first one on the left here is an analysis by speed. So how fast are people flying their drones? Are they actually in compliance with less than that 100-mile-an-hour threshold? And so again, we kind of see what the normal behavior pattern looks like. The most are flying their unmanned aircraft at a relatively slow speed, from 30 miles an hour, and in many cases, 5 miles an hour. But we do have a very small number up here at the higher edge of that, at 60 to 70 miles an hour. That's abnormal. And as we see abnormal, now we know what we should start to flag and what should concern us to raise the hairs on the back of our neck, if you will, to understand what is really going on out there. Another great example is understanding beyond visual line of sight flight. One of the ways that we do this is we have the ability to identify the unmanned aircraft operator's launch location, and then we can measure based on the size of the unmanned aircraft and reverse calculate to what's known as 1 arc minute. 1 arc minute is a 60th of degree and is largely considered to be the capability of the human eye, the ability of the human eye to see at a maximum distance. Now, the FAA doesn't necessarily dictate what the visual line of sight should be, but if we compare that to what the capability of the human eye is, we should get a pretty good idea. Additionally, we can plot over time to better understand, well, what are the distances that people are flying beyond visual line of sight. We get some interesting traffic counts. And as we compare that, obviously it looks pretty bad as we actually look at the numbers that we're seeing here. We're jumping from 500 drones to over 2,500 drones that are flying BVLOS, less than a statute mile alone from 2018 to 2020. But as we continue to evaluate that data, the story changes a little bit. So if we looked at it proportionally, we would actually see that no, it's actually a relatively stable proportion of unmanned aircraft that are flying BVLOS because the population of the drones is increasing. So again, it matters how you look at the data and the perspective that you're using. Additionally, I would show you that there's a lot of other information that this data can tell us. This is another example from the same data collection location that you saw earlier. In this case, we're looking at when unmanned aircraft systems were being operated outside of sunrise and sunset hours. In other words, when they're flying at night. And this is, of course, before the FAA instituted the new rules that allowed for that activity. And you can see that there was a surprising amount of unmanned aircraft systems activity that was occurring. But again, we're leveraging that GIS data. In this case, we're looking specifically at sunrise and sunset data, fusing that with drone detection data and understanding what activity was happening. There's a lot of things that we can't predict. A good example is someone asked, well, maybe those unmanned aircraft had a waiver, which is totally possible. We can't unfortunately see that in the data. So we can only report based on the data that we have access to, and we have to understand what the limitations of that data are as well. But we can fuse it and understand what is it actually doing? And so some things that we can take away from this, we see that unmanned aircraft operators tend to favor the weekends. Well, that doesn't really surprise anybody. Additionally, we see that they tend to favor the later evening hours. We can make some relatively reasonable social assumptions about that. For example, people get off of work and they go and they fly their drone. And I think that's kind of interesting as we look at some of that activity. Additionally, you can kind of see the same effect that's happening here that we talked about earlier. If we look at the raw data, it actually looks like there is a more serious problem that people are flying more in the evening or at night. But the truth is, that's not really true. When we look at it proportionally, it's about stable. We actually see that stability. In many cases, it's actually being reduced. So again, it's important to look at data through different lenses to make sure that you understand exactly what the data is doing and what it really means. Some other things that we've done to make the data more interesting is we've actually overplotted, and you can see the overplots here in amber as well as in gray, when an unmanned aircraft should not have been flying based on the weather. And this is based on the Part 107 restrictions requiring 3 statute miles of visibility and the cloud ceilings. And so as you look at this information, now we can kind of question, there were unmanned aircraft flights when the local airport within their proximity was reporting weather information that should not have allowed them to fly. And so by leveraging historical ASOS information from the Iowa State Mesonet, we now gain additional information about maybe some other problems that there should be to address out there. So I think that's kind of interesting as well. And perhaps one of my most favorite is, as you better understand what is going on with the data, you can get some very interesting information out there about what's happening in the industry. And this is a great example of the monthly active population of UAS out there at this particular sampling location. And one of the things you immediately can pick up on is there is a very strong seasonality to unmanned aircraft flights. We see the same thing in the sighting reports, is over the summertime, we see a generalized spike in the number of reports. Well, that is very, very closely related to the fact that there are more UAS out there flying during the summertime. In addition to that, you'll also note that we've broken this down by model and platform. And from a business sense, I think the value of this data is particularly important because we can see the historical evolution over time. If you knew exactly when the iPhone 5 was going to be replaced with the iPhone 6, that would be pretty important information. We can start to better understand how that data looks. And I'm going to give you another perspective that might make it a little more clear. If we use this information proportionally, we can very quickly see what is actually going on here. And I'm going to give you a classic example of this. If you look at the grayscale is the scale that represents the Mavic. And the Mavic aircraft, probably one of the most popular of all time, the Mavic Pro, you'll note from 2018 onward, its market share, we'll call it market share in the sampling location anyway, has been diminishing over time. Well, what is actually happening there is we're seeing that market share be exchanged for market share in other platforms that have been out there. Good example, the light blue, the Mavic 2, has started to gain prominence and to a certain extent has maintained its prominence over time. We see the orange, the Mavic Air, never really became a significant market share player. And so it's very interesting to start to track exactly what the market looks like as we understand what the components are. And I'll take it a step further. What can be leveraged from this on a security or safety perspective? If we know what the market is, if we know what is being flown out there, we also know what the threat looks like. What are the capabilities of some of the different platforms? And I'll give you a classic example. We now start to see in this peach color here, the rise of the FPV drone. We now understand that that drone has different capabilities, and we can have a certain expectation of the measurement of how many of those drones we see in this market and what to expect by that capability. So I think it's very interesting to look at that data set. Because we're also able to collect information about serial numbers, and I'm going to highlight by saying these serial numbers are non-identifiable. They're just a series of numbers, and we can connect them together and show activity for platforms. We can't actually connect them to people. But we can develop some very interesting analytics that see when unmanned aircraft are entering into the market and when they're leaving the market. So in other words, we are calculating the first time that we saw a unique serial number and counting it. And we're also counting the last time that we saw that serial number. In other words, when it exits the market. And from that data, we can really garner some very interesting information as well. Now, I got to warn you, you got to be a little careful in interpreting this data because you'll notice that it's heavily skewed on the back end. Well, why is that? because this was the last month that we collected that data. So of course, that is going to artificially look like there are more platforms exiting the market, because that is in fact the last month that we detected them. If we were to continue this for 6 months or a year, it's very likely that we would see a very different pattern over time. So in other words, the accuracy of the market exit data is going to be much more accurate at the early onset than it is on the later onset. So again, kind of a warning about how to interpret information from some of these charts. But what this allows us to do is to now figure out and calculate a lifespan of the unmanned aircraft. And again, you got to be a little careful in how you analyze this data, but over time and with large data sets, we can actually understand what percentage of the population of that drone type are still in use after X number of months, and we can make that calculation. Again, you have to be a little bit careful in interpreting the data. You'll notice that particularly the newer platforms, the Mavic Air 2, the Mavic Mini, and so on, they are going to be skewed. In other words, they're going to look like their lifespans are artificially short, and that primarily that's due to the fact that we haven't collected long enough data. As you have much longer series of data, like we have with some of the other platforms, the Phantom 3S and so on, those numbers become much more accurate. Perhaps what's very interesting is you actually see this very precipitous drop, and we see this across almost every platform. We're going to call this one of the interesting findings, and it's the hobbyist closet effect. The idea that as a hobbyist, you go out there, you buy a drone, you fly it a lot your first month, and we've determined that number is about 25 times. And after you had your fun with it, it goes in the closet. And I think it's very interesting to see that effect take place, because that is actually pulling out somewhere between 50 to 60% of the market share after the first 30 days. And so I think that's really interesting to start to understand that data and to advise upon that data as well. Other interesting activities that we're performing, we're looking at the LANC system. You can see the top left chart here, identifying when the low altitude authorization notification capability is effective, comparing unmanned aircraft against the GIS-centric data set of when authorizations are taking place, and evaluating whether or not they're actually in compliance with the local grid. Are they flying above the maximum altitude of that allowed grid? And then we can further take that information and better understand, are they flying near aircraft? Do they actually pose a threat at an airport? In the bottom left, you can actually see another chart of another interesting series of analytics we're doing. Again, looking at that BVLOS capability that we've evaluated before using the 1 arc minute criteria. We can actually break down the segments of each flight and its telemetry and look at the components of that flight where that were beyond visual line of sight. So in other words, what is going on with the unmanned aircraft as it can no longer be visually observed from the operator, or at least what we perceive as not being able to be visually observed. And so that's another interesting component. We ask ourselves, why is the unmanned aircraft doing what it's doing? Should that flag us to look at it further and ask ourselves, is this an illicit response? Is this an unsafe action? Do we need to look at this data further? And then finally, looking at the origination point of where unmanned aircraft are actually coming from. And I think you can see the very logical application of this by saying, where do we need to post signs to tell people that they can't operate an unmanned aircraft system in this area? And a good example might, I might have originally said, well, parks, because it's a very logical location for people to fly. It's a wide open territory. But the truth is that's not what the data is showing. We're actually seeing that the most people are operating is actually from their home. They're launching off of their driveways. And so it becomes very interesting to better advise where to and how to respond to some of these different locations. So I think it's interesting as we start to look at data and start to understand that data, how do we then use that and leverage it to advise us about how to move forward? So in conclusion, I think it's really important to note that drones still represent a novel and largely unmitigated threat. We don't know all the capabilities that are going to be used in an illicit fashion yet. So I don't think that we can really put down our guard. And more to the point, that the law enforcement agencies out there, I think, are at this point unprepared to respond to this threat. And as we transition over to some of the data that we looked at, there's truly a lack of scalable data sources that really adequately measure what is the state of small unmanned aircraft system operations within the national airspace. There's no large radar network or RF detection network, at least now, not until remote ID becomes a reality, to be able to look at this and say, what is really going on out there? So we have to leverage other sources. Where we do have UAS detection data, it can truly be a force multiplier because now we can start to better understand the landscape about what is normal behavior and then what is abnormal behavior, and allowing us to flag those abnormal behavior operations to better understand what is going on. And then finally, that UAS detection sets really provides a much more holistic picture if we fuse it with other kinds of data sources that we talked about. I will highlight, just as a caveat, that all the data that we've talked about has its own unique limitations. It shouldn't be taken at face value, and it's important to understand the limitations and, perhaps more importantly, the generalization of what can and can't be done with that data. So you can't say just because you saw a presentation today that the drone industry is growing or a certain type of unmanned aircraft is gaining prominence. There is more to the story, and you have to understand what the limitations of that data are before you can take it and run away with it and generalize what's really going on out there. So I just want to highlight that potential limitation as well. It was a great pleasure to join you today, and I'm certainly happy to invite any questions that you might have about this presentation.
Oh, perfect. It was really, really interesting and lots of data there, which is one of my favorite things to see. So appreciate it, Ryan. I'll get you to keep your slides up because there was one question about the insider threat flight path, or those flight paths you mentioned. If you're able to maybe tack all the way back there. The question was, are those small square boxes a change in direction of the drone, or is that where photographs are being taken?
Great question. So actually, each of those boxes is a telemetry sampling point from the sensor that we use. So in other words, every time the sensor received a hit, that is one of those plotted points.
Okay. And the follow-up question to that was this DJI detection only for DJI make and model drones, or did it include
That's
other
correct.
makes and models?
Yeah, so this is DJI detection only. And of course, my focus area is how to leverage that data to the maximum extent possible. And I think you bring up a really good point. We are only looking at DJI. There's another 30% of the market share that isn't accounted for.
And that 30% is growing, as we see the blue SUAS and different elements, requiring other kind of homemade drone brands. So quite interesting. Okay. And again, another point on your slide, there was the assessing UAS threat capability, which is your threat model page. And the question was, is budget a factor? It doesn't seem to appear there. Or should the financial capacity of a threat actor be a factor in this?
I think it absolutely is. And I'm going to say that, this assessment of the threat is not holistic. There's certainly many other components that we could include on there. And I think cost is absolutely something that needs to be considered. The cheaper the drone, the more disposable it becomes. And so I think that's another factor that has to be carried out. This is just one of many different ways of looking at threats and to understand it from a capabilities perspective. But I think you bring up a very good point.
And this is just a question for myself, but given there's been one or two threat models done on drones, but obviously we're now looking in the context of both swarming technology and other newer drones that are emerging. Are you aware of any other threat models that could be pointed to for other viewers in terms of resources or a literature review type thing?
Not that I'm aware of that have been published. So I'm certainly aware of a few works out there, but it's my understanding that they haven't been published yet. I know the Department of Homeland Security has some materials that might support that, and they are open access for anyone that wants them.
Okay. Next question here was on the measurement of scale, and it says, are there many post-event analysis of validating whether it was actually a drone or not? And can this only be achieved where you have a drone detection system already in place?
That's a great question. Validation is a particular problem. And so anytime you start dealing with validation issues, you got to look at where the data is coming from. I think that drone detection equipment, depending on the kind of equipment, can help. But even that data has certain limitations. So for example, a radar is going to show you that there's something out there, but it's not going to tell you what it is. I tend to favor RF style units because now you start having some level of validity. You can compare it to certain expectations. So in other words, we can tell when a drone is emanating a certain type of a signal set that is configurable, and we can identify that unmanned aircraft. So I think like any other data source, it has certain limitations.
Okay, no, that's really interesting. Next one was on your fusing UAS data. And the question is, what are the current legal repercussions of drone tracks, or actually tracking drones with UAS detection? is there any data legalities on sharing that data?
In sharing that data? That's a great question. So, some of the work that we do is obviously working with agencies that have the ability to look at this in a greater level of detail. In terms of sharing the data, I'm not aware of any restrictions here in the United States in terms of any problems with sharing that data. I think you'll find that most people that have that data are unwilling to release it because of the proprietary or the security or the safety nature of the data. So I think there's other issues there. There have been a few instances where Congress has attempted to make certain types of detection technology illegal. In some cases, there's still some questions about the different types of technology out there and the legality of it. So I would say that there's still a gray area there, is probably the best way to answer that question.
Okay, no, that makes sense. And I'm sharing a YouTube comment as well, and it says, "Awesome presentation. Can you please elaborate further on the technical side of the data collection? Was it done through an SDR on a 2.4 to 8.8 gigahertz?"
Great question. So we primarily use the DJI Aeroscope device. I know there's certainly several limitations associated with that device. It is limited to collecting on small unmanned aircraft systems that are manufactured by DJI, and then we leverage that data set. Inside that data set, we can actually go in and do quite a few of the analytics that you saw just using that data and then fusing it with the other data sources that you see that are presented on the screen.
Okay, perfect. And this is just from my side. I'm really interested to hear what's next on the radar for Embry-Riddle. I mean, you've been doing some of these, research focused experiments or hypotheses to try and collect that data with various ports and things like that. Number one, what's next on the agenda, and how much of it is going to focus on, say, critical infrastructure versus, say, just general?
Great question. So critical infrastructure is obviously a target area. The other thing that is of great interest is better understanding when unmanned aircraft and manned aircraft are coming in close encounters with each other when they are not being reported. So as we start fusing particularly the UAS detection data with aircraft ADS-B data, we can now understand what that looks like. How many are we missing? How many near misses have occurred without us even knowing about it? So that's a component that is moving forward. And then quite a bit of the data fusion on a scalable result. So beyond one sensor, now we're going to expand it on a much larger scale.
Okay. And just in regards to the slider on front of you, you've got weather and time data. When could you determine, or what kind of insights could you pull from weather data, and why would that be important in drone tracks?
That's a great question. So, kind of as I showed you on one of the slides, we can overlay that data and understand if there are compliance issues with individuals flying their unmanned aircraft when the reported weather says that they should not be able to based on a compliance element. So, that's kind of, I think, a really important thing to look at holistically what compliance looks like, not only in terms of altitude or airspace, but also understanding when people are flying that they shouldn't, when the weather doesn't meet the requirements that are set forth by Congress.
Mhm. Terrific. Well, Ryan, thank you very much. I'll get you to end your slide sharing screen now, so it'll just be us. But thank you so much for your time today. It was really interesting, and I'm sure others can contact you if they have any other further questions or things like that. So thanks for joining us.
Been my great pleasure.